Okay, good morning. Can everybody hear me in the back? Okay, after Eric and John talking about wireless, my name is Erik-Jan, and I'm not going to talk about wireless, although I have a microwave and a baby. Okay, I'm going to talk about the next generation internet in the Netherlands and Europe. I work for a company named SURFnet, and just do a show of hands. Who of you has heard about SURFnet before? Okay, and of the people that just put up their hand, who thought that my company would be spelled TERFnet? Okay, great. That doesn't explain, though, why I get so many emails destined for knock@terfnet.net. But okay, I want to take you between now and the coffee break through a number of items. First of all, a short introduction of my company and the country I come from. Some words about the overall project. We are just starting now. The official launch date of the project was 2 months ago. It's called the GigaPort Project. One of the two main aspects of the project is GigaPort Network, and we are building the next generation internet in the Netherlands inside this part of the project. We have had some generations of our backbone, and currently the backbone is called SURFnet 4. I know that here in the US people are talking about Internet 2. Well, we have SURFnet 4. We are building the next generation network inside the GigaPort project, and that will be called SURFnet 5. And finally, I will talk about okay, this is better, I think. Good. And finally, I will be talking about some access infrastructures because we identified that access to the backbone is one of the critical aspects. Okay, for those of you who have heard about the Netherlands but wonder where it is, this is a map of Europe, and the red circle is the Netherlands. And the Netherlands is 6 milliseconds tall, measured in round trip times on OC12. And 4 milliseconds wide. Okay, when you look at the transatlantic bandwidth in use to and from the Netherlands, you see this nice graph starting in 1992, ending this year. And here you see the dark blue is the telephone system, and the shaded blue is internet bandwidth currently in use. And as you can see here at the level of this year, 2 gigabits per second for telephone, and, well, approaching 5 gigabits per second for the internet. Right, some words about the company I work for. We are the National Research Network in the Netherlands. We are established in 1987, and we serve the research and higher education community in the Netherlands. We have roughly 200 customers in the Netherlands, and those 200 include the 14 universities we have in our country. We are a commercial company, but we are a not-for-profit company or a non-profit company. And also not for loss, I should say. The connected sites, the 200 customers, they pay for the service they get from us, but the Dutch government pays for the innovation we do. And I'm now talking about the GigaPort project in a few slides, and that is paid by Dutch government. Okay, here's an overview slide of the GigaPort project. We are building the next generation internet in the Netherlands in a 4-year project which started end of March this year. As I just said, there are 2 main components to the project, and one of them is to build applications. We call it components for application and services. This includes middleware, whatever that is. And this is done by the Telematics Institute, a consortium of research institutes and commercial companies that do telematics research in the Netherlands. And then there is the network component in which my company is engaged. The project itself, the entire project, the GigaPort project, was a joint initiative by 3 ministries of the Dutch government, of SURFnet and the Telematics Institute, and a number of companies like Cisco Systems, Lucent Technology, Ericsson, IBM, and what have you. All their branches in the Netherlands. My country doesn't have a government anymore. They were sent home a few days ago. But just before that happened, they granted 85 million US dollars, which is 160 million Dutch guilders, to the project. So that is secured. And a large portion of this money is going to the network. 70 million US dollars is going to the GigaPort network portion. And this is our budget for the coming years. Okay, I'm now going to talk just about the network component. I'm a lower layer type of guy, so I would like to stick with that. The goals we have for the period until the end of 2002 is the development of a highly advanced infrastructure. And all our 200 customers, they should be able to be connected to this new infrastructure, say, end of next year, beginning of 2001. Then the network should be really there. And also the network should be enabled for testing of advanced applications by commercial companies. And that is the pre-competitive research that is allowed on the network. I just elaborated on the fact that we serve the higher education and research community in the Netherlands, so this is an exception to that. At the end of 2002, we expect that there is a new network, a completely new network, SURFnet 5, and by that time we will remove the SURFnet 4 network. And how that looks, I'll come to that later. And at that moment in time also, at the end of 2002, we hope to have the experiences with new IP features and new network and access technologies. And regarding the access, I'll come to that at the end of my presentation. Okay, if you zoom into the GigaPort network portion of the GigaPort project, there are three main components. First of all, there is the national research infrastructure. SURFnet 4 is available now. SURFnet 5 is going to be built. To do the testing of the advanced applications inside the GigaPort project, SURFnet 4, as I said, is available now, and we will be using this infrastructure for all the application testing. An important and expensive component of the project is the external connectivity. Currently, we have bandwidth into Europe, connections to the Amsterdam Internet Exchange, the local exchange in the Netherlands, and we have transatlantic bandwidth going into the US. And I'll zoom into that later, but this is also the main funding part of the project. I mean, the 70 million US dollars I talked about is going into this portion for quite an amount. And finally, the access networks are also part of this project. Okay, this is a schematic overview of how the network will look like. Here in the center, there is the national research infrastructure. Currently SURFnet 4, real soon now SURFnet 5. Just around that are the access networks. And that can be projects for doing wireless or wired access to the network, or it can be the connections of each of the customers we have towards the network at speeds I come back to in a few slides. And then on the left side of this picture, there are the three external components we have regarding international connectivity. Okay, we have some aims defined for the network, and for this year we hope to have IP over WDM between several POPs of our backbone. But if you look at the aims for the end of the project, the numbers you see here are the numbers we hope to reach at least. I mean, if we can go further, we want to extend it further. And especially when I look at external connectivity to North America and to the rest of Europe, we aim for STM16, as we call it, or OC48. But we hope to expand beyond this. When I talk about backbone links, we expect them to be 80 gigs. I'm not talking about aggregate bandwidth, I'm talking about individual links at that speed. And we see the SURFnet 5 network being built as an evolution and not as a revolution. If I go back in time, back to when SURFnet was established in 1987, we saw that we used X25 on 9.6K. And if you look at this scale, at this picture, you see that the 20 gigs we hope to reach at the end of 2002 is just a straight line coming from 1987. This is where we are now. I mean, this is the network that is there, SURFnet 4, and we can connect customers at OC3. This is a planning sheet for people interested in OC layers 8 and above. But the main part is here, the middle part. We are currently in the piloting phase, and that's why I said we hope to be able to do IP over WDM between several POPs end of this year. And that's still piloting phase. And then in the pre-production phase, which comes directly after that, we hope to be able to connect the first customers to that. And those customers will still be connected to the old network, SURFnet 4 at that time. And then the end of the project is the scaling up phase, in which we convert all the customers to the new infrastructure. The backbone should be at production level, which means certain availability guarantees, etc. And then we enter the production phase, which will last for 3 more years. So if I look at the whole SURFnet 5 network, we started now for the definition phase and the piloting phase, but it will be running until the end of 2005, as we think. And the above part of the slide says next generation. I think it will be SURFnet 6 or whatever. Okay, here's a picture of the Netherlands, and that is the right side, I mean. This is our backbone, spanning the 4 large POPs we have. One of them is in Amsterdam, and all the lines you see are OC12, or parts of OC12. I'll come back to that later. And here you see all the other POPs in the Netherlands we serve. And all the 200 customers are connected here to each of the POPs. And the line going into the sea are the external connections. We use Cisco's 12,000 series. This backbone was built a year ago. And, well, this was available at that moment in time for doing the production stuff. This is looking into the core of the backbone further. The 4 main locations, we call it GigaPops. The GigaPops are connected at multiple OC3s. I talk about OC12 speed. The local carriers in the Netherlands at that moment in time when we started building this were not able to do STM4 or OC12. So we had to go for multiples on OC3. When you look at the SURFnet standards, there is this beautiful thing of concatenation built in. I mean, OC3 155 MAC is OC3C to be precise. When you look at the SDH standards, it's STM1, and the next one is STM4, which equals to OC12 speed. But then you have STM4 and STM4C. And here's the whole issue of concatenation, which is a problem in SDH. And when you look at, for instance, Cisco, at the moment in time we were building the backbone, they were able to do STM4C. But the local carrier was not able to do STM4C, only STM4, and then with some problems. So that's why we went for the multiple OC3s concatenated. Okay, some words on external connectivity out of the backbone today. We have 3 main types of external connectivity. One of them is to the Amsterdam Internet Exchange. It's 200 megabits per second right now. Another one is to the US. It's depicted here as the rest of the world, but it's the connection to the US. It's 200 megabits as well. It's OC3 plus DS3. And into Europe, we have a 155 meg connection. And the black figures on the various lines depict where we want to go at the end of 2002. Okay, some words about US connectivity. As I said, we have 200 megs between Amsterdam and New York City, where we have our own POP. We have a commodity internet connection into Teleglobe, into the Globe Internet. We have a startup connection. We are present at startup on DS3 level. And the external connectivity right now is a scarce resource, as we call it, and we want to be able to put some classes of service enforcement methods on the lines we use right now. And for that we use the car and waited for queuing features to make sure that certain users are not getting the whole line. And we just started to look at MPLS-TE traffic engineering, to make sure that the traffic between the US and Amsterdam is routed in an optimal way. If I look at the peerings we have in the US, just besides the internet the commodity internet connection to Teleglobe, it's Abilene, ESNet DRN, and 2 universities in the Chicago area, or in the Illinois area. When I look into Abilene, we have 2 connections to Abilene. One is at Startup, and one is a direct connection in New York City. We happen to be in 60 Hudson Street in Manhattan, and Abilene happens to be there as well. So that's pretty convenient, and we have a fiber that we share with NordiNet, which is the Scandinavian research network. Okay, soon we hope to have peerings with a couple of other networks at Startup as well. Okay, the next generation backbone. How are we going to build this? Well, we are currently working on the creation of partnerships. There are a few telcos in the Netherlands. The Netherlands is a liberated country as far as telecommunications is concerned. There are quite a few right now. And we look at people that have the fiber, people that have the transmission equipment, and we look at people that have the routing equipment, and we would like to partner up with them. As soon as possible, we like to start with IP over optical networks. I mean, I said IP over WDM, but that can evolve in time as well if the technology evolves. We are looking at new features now. I mean, SURFnet 5 is not there yet. SURFnet 4 is there and is available for use. And well, we are looking at all kinds of different IP features right now. And multicasting is one of the things we are involved in heavily. And together with NordiNet, as I said, the Scandinavian research network, we are doing MBGP, MSDP stuff towards the network inside Europe, the 10155 network. Some of you might have heard of that. And we are connecting to Teleglobe using the new features as well. And one of the projects we are engaged in is together with the national broadcasting company. And one of the things we want to do, or are doing right now, is have the 3 national channels on multicast on our network. And one of the ideas we have is to have this multicast stream going to the US on our Abilene connection for Dutch scientists that are visiting in the US. They can see Dutch television there. Right, some words about access infrastructures. What we see, at least in the Netherlands, is that access networks are running behind. And our aim is to have high-speed connectivity always and anywhere in the Netherlands. And we are currently in the process of concluding partnerships for 2 types of access, that is wired and wireless, and we hope to have pilots up and running this year, 1 for wired and 1 for wireless. Right now there is an ADSL trial in Amsterdam which has been going on for more than 2 years now. That's with KPN Telecom, 1,000 connections on ADSL, 2.5 meg downstream, 700K upstream. And well, SURFnet is involved in there because we are delivering the internet connectivity to this trial. And as I said, we are involved into the project with the national broadcasting company, and they're the other partner, and they supply the national TV channels and delay TV and video archives to the project. Regarding wireless, we are researching to see whether we can, inside the project timeframe, do UMTS. Eric this morning elaborated on GSM and GPRS, but the next generation of mobile and then in the telephone business enabled for data as well is UMTS. And when you look at the standards definition, well, it's close. Whether we will be in time, 2002, 2003 maybe, when the first projects for UMTS will be installed in the field. And that would enable 2 megabits per second through, well, mobile telephones. Okay, we're not just building the network, as I said. We look at, well, all these items as well, like the authentication and authorization for access to the network. What we learned from the ADSL trial is that just supplying the bandwidth is okay, but when people have to start paying for it, you want to make sure that the people that are using the services, using the bandwidth, are authenticated and are indeed allowed to use the network. Okay. Well, this is the last slide I have, so I think I'm running 5 minutes late for coffee. If you want to have more information on the project I just elaborated on, please look at www.gigaport.nl. We hope to have a meeting. We are planning a meeting in the Netherlands, in Utrecht to be precise, on June 16 for giving more information on partnerships we are looking for inside the project. It will be made public on the webpage I just showed here. Okay, thank you for your attention. Are there any questions?
Questions going once, going twice?
Okay, thanks.
Okay, thank you.